Yeah, good morning and warm welcome all the participants in the final day of the 3-day online course of the Ecosystem, Biodiversity and Climate Change, which is jointly organized by Rajiv Gandhi National Institute of the Youth Development, Tamil Nadu, Society for Environment and Development, India, New Delhi, and Sri Venkateswara College, University of Delhi. In the first session, we are taken to the fourth talk. First talk is delivered by the Dr. Nisa Mehdi Ratta from DST. Second talk is delivered by the Professor C. Rajsekharan. Third is the Dr. Syam Singh Partiyal from Nalanda University. And Professor Rana Pratap Singh from Baba Saheb Bhimrao Ambedkar University, Lucknow. In the second day, we are again the fourth talk. First one is the Dr. Chuba Jamir from the Terry School of the Advanced Study. Second talk is the Dr. Y.B. Singh, ex-director ICR, Central Soil Salinity Research Institute, Regional Research Station, Lucknow. And third one is the Dr. Amit Kumar Gupta, additional director, Regional Office, Lucknow, Ministry of Environment, Forest and Climate Change. And fourth lecture was delivered Dr. Sivaji Bagar, Department of Botany, Swami Shraddhanand College, University of Delhi. And today we are again the excited and the fourth lecture. And it session is divided into the two part, morning and evening. Morning session with the start with the invited talk impact of the improver of the solid waste management on the climate change NXS approach and delivered by Dr. Rajiv Pratap Singh, Institute of Environment and Sustainable Development, Banaras Hindu University. And second talk will be delivered by Professor C.P. Kaushik on climate change and environmental sustainability, retired professor, Department of Environment and Technology, Guru Jambheswar University of Science and Technology, Haryana. And the second session, which will be held on the from 2 p.m. to 4:30 p.m. Again, the two lecture. First one is the invited lecture, Humans in the New Geological Age, and delivered by the Professor Chand Kumar Tripathi, School of Environmental Studies, JNU. And second lecture is the invited Ecosystem and the Climate Change, Approaches for the Ecosystem Restoration, delivered by the Dr. J.S. Chandrasekhar, Department of Environmental Sciences, Karnataka State Open University, Mysore. And finally, we are the valedictory session. So in the morning session, we are the invite to Dr. Rajiv Pratap Singh. And before inviting him, I invite to the our organizing secretary, Dr. Sunita Yadav, assistant professor, Department of Botany, Sri Venkateswara College, to introduce to the our first speaker. Over to you, ma'am.
Thank you so much, sir. A very good morning to all of you, and welcome to the third and the last day of this online course. So it is my privilege to introduce Dr. Rajiv Pratap Singh today. Good morning, sir, and welcome. Dr. Rajiv Pratap Singh is an assistant professor at the Institute of Environment and Sustainable Development, Banaras Hindu University, India. He completed his PhD degree also from the same university. His main research interests include solid waste management, biocomposting, and green technologies. He has been a recipient of several international awards, including the Green Talent Award from the Federal Ministry of Education and Research, Germany. Also the Netscopus Young Scientist Award, the DST Young Scientist Award, and so on. He is a member of the editorial team of various scientific journals, and also he has edited more than 8 books and around 50 highly cited research and review articles on solid waste management and ecotoxicology. His research works are well cited by the researchers globally, with a Google Scholar citation of around 5600, H index 32, and I10 index of 52. He has also received the Water Advanced Research and Innovation Fellowship from DST. Also, I use SSTF, University of Nebraska Lincoln, and the Robert Daughtry Water for Food Institute. He's also a fellow of NAAS, the National Agricultural Academy of Agricultural Sciences, Delhi. So with this brief introduction, we welcome you, sir, and the virtual dice is over to you, sir, now. Thank you. Rajiv, sir, please unmute yourself.
ओके चलिए चलिए अब है आवाज आ रही है आवाज आ रही है
Yes, sir, you are audible now. Yes, sir.
okay thank you
Yes.
As we know that now we are having a lot of pressure on our land and the urban we are moving towards urbanization. At the time of independence, the urban population was around 17.3%, and in 2021 it is assumed to be 35% and will be about 40% in 2031. Urban population is increasing at the rate of 2 to 2.5 per annum. Per capita solid waste generation ranges from 0.17 to 0.62 kg per day, with annual increase of about 1.3%. Presently, India produces about 62 million tons of MSW, municipal solid waste, which is likely to reach 165 million tons by 2030 and 450 million tons by 2045. Whereas about the collection efficiency is concerned, it ranges between 50 to 90% as per the city and condition. It is estimated that in developing countries, approximately 80 to 90% of the MSW is disposed of in landfills without any proper management practices, and open burning is very common, which leads to air, water, and soil pollution. Urbanization and industrialization, along with technical advancement and expansion of cities, has also led to increased amount of solid waste generation. The per capita waste generation is largely dependent on socioeconomic status, living standard, and consumption pattern of that particular country or city. The unscientific management of waste disposal continuously emits greenhouse gas, which is ultimately contributing to global climate change. The sustainability challenges with the waste management is one side it is pollution, climate change, ecosystem and biodiversity loss, waste generation, whereas the depletion and shortage and price shocks is also concerned. Import dependent economic insecurity is there, and conflict over access of resource is also there, because the waste management creates improper waste management creates natural resource extraction and use and disposal problem also. As far as waste and climate change is concerned, climate change is a serious international environment concern and subject of much research and debate in recent years. It is estimated that about 4% of greenhouse gas is emitted from waste sector and contribute to 1/5 of global anthropogenic sources. Compared with other 15 sectors which are listed under Kyoto Protocol, controlling and reducing greenhouse gas emissions from waste sector seem to be cost effective through appropriate waste conversion technologies. Greenhouse gas emissions and savings are attributable to various stages of waste management systems. Waste contains organic materials such as food, paper, wood, and garment trimming, etc. Methane emissions from landfills are generally considered to represent the major source of climate impact in the waste sector. Under anaerobic condition prevalent in the landfill, the microbial communities contain methane producing bacteria. As the microbes gradually decompose organic matter over time, methane about 50%, carbon dioxide about 50%, and other trace amount of gases are generated. This figure shows, pie chart shows the greenhouse gas emission by different sectors. You can see that about around 24% of the greenhouse gas emission is done by agriculture, forestry, and other land uses changes. 14% is by transport sector, 25% by electricity and heat production. This figure shows the trend for greenhouse emissions from waste. In 2020, you can see the blue lines, which is landfill methane, red wastewater methane, green wastewater nitrogen dioxide, and purple is insertion CO2. The greenhouse emissions from waste disposal practices. The waste sector is accountable for about 5% of global greenhouse budget, with total approximately 1,300 metric ton carbon dioxide equivalent in 2005, according to IPCC 2014. This 5% consists of methane emissions from anaerobic decomposition of solid waste and carbon dioxide from wastewater decomposition. Only methane is accounted for the emission of greenhouse gas emission from solid waste management practices, not CO2, despite its global warming potential upon release. This is due to the general consensus that CO2 from waste decomposition is of biogenic origin and hence do not add to the overall greenhouse gas emissions that contribute to global warming. The global emission from waste sector has doubled from 1970 to 2010. Both landfill, waste incineration, and other and wastewater treatment emit significant amount of methane. This figure shows some of the improper waste management. We can see that we worship at home and throw the worship material in the river. The open burning is very common. Disposal on nearby the water bodies were also some common in other places, and the transportation is not scientifically recommended. This is the simplified schematic diagram of waste management system and greenhouse emissions. You can see that at different points from source to landfill, at several points the greenhouse emissions can be produced, and if we want to check the greenhouse emissions, we have to manage these things properly. Alternative for solid waste management disposals. Globally, landfilling, vermicomposting or composting and incineration are considered as the most common treatment technologies for MSW or other organic waste. Among landfilling is expected to increase due to adoption of landfilling technology over open dumping by most of the developing countries. Various independent studies have suggested a large variation of greenhouse gas generation from 1 ton of waste, ranging from 40 to 250 meter cube. This is understandable as landfill gas generation is highly dependent on variety of factors. One of such crucial factors determining greenhouse gas emission is waste composition. Means the organic component will increase, thereby the greenhouse gas emission will also increase. However, there has been a movement to divert organic waste from landfill to other technologies in order to reduce the negative environmental impact. This slide deals with one of the technology, vermicomposting or composting. The vermicomposting and composting technologies thus has been widely acknowledged as an alternative to landfills. Aerobic digestion from well-managed composting results in emission of CO2 and water. Due to heterogeneous nature of vermicompost or compost pile, some methanes form within the piles may enter from anaerobic pockets. The studies have shown that majority of this methane get oxidized into CO2 in anaerobic pocket and near the surface of the compost pile, making methane emission negligible. Not all of the waste can be composted or recycled, and a certain portion of inedible waste will be landfilled. This shows how the composting helps the environment. Methane is the greenhouse gas that is over the course of 20 years 72 times more potent than CO2. Composting decreases the greenhouse emissions, you know, that is methane, and you can minimize the waste going to landfill also. So the load on land can be minimized because land is precious. Second technology is incineration. It is just a burning at high temperature in contact of air. Estimated current greenhouse emissions from waste incineration are rather very small. Globally, about 130 million tons of waste are annually composted in more than 600 waste to energy treatment plants in 35 countries. Although some pilot models have proved successful in developed countries, many details are yet to be determined in terms of implementation, necessitating further research work. The global market for biological and thermochemical waste to energy technology is expected to grow to, to 29.2 billion USD by 2022. The waste to energy technology not only helps in minimizing the waste crisis, but also meet the actual high demand of fossil fuel and to reduce the greenhouse emissions and climate change impacts. This is the example of Indore city, how they are handling the waste. And in Swachh Bharat mission, the Indore Municipal Corporation is getting always on the top position. Earlier, Indore Municipal Corporation introduced a three-way source segregation in 2019 for wet, dry, and hazardous domestic waste. Thereafter, a year later, it urged its residents to follow a five-way source segregation: wet, dry, hazardous, e-waste, and sanitary, to improve the purity level of waste that can be recycled. In January 2021, the municipal corporation added plastic waste as the sixth component. Today, the waste in the city that is used for composting is 99% pure, while the recyclable dry waste is 99% pure. The municipal corporation has taken an authorization of sending 1,000 ton of domestic hazardous waste to a treated facility every year. Now, the Bhopal is another city in the country that has made some progress, and they are following the Indore model. Now it comes to that the saving the paper. That if you save 1 ton less paper, it will save 17 trees, 380 gallons of oils, 6953 gallons of water, 587 pounds of air pollution, 4,077 kilowatt of energy, and 3.06 cubic yard of land space. And you ultimately help in combating the climate change. As far as the plastic pollution is concerned, every year the world uses 500 billion plastic bags. Last year, more plastic bags were produced than in the whole last century. 13 million tons of plastic end up in the ocean each year. 50% plastic used in single use or disposable. 1 million plastic bottles are purchased every minute around the world. 10% of the all waste generated is plastic. Now, earlier it was 3R, then 4, and now it is 6R. 6R principle of waste management. Before you use anything, first rethink is if it is environmentally not friendly, you can refuse it. Even though you are going to use, try to minimize it or reduce it. The rules, you can reuse it, recycle it, And then if there is no option, you can replace with the sustainable things. As well as the waste hierarchy concern is the concern the disposal option is least preferred, as well as the prevention option is most favored option. The waste can serve as a biorefinery of several products, like agriculture biorefinery. It can be used on all type waste generated from agriculture industry activities, and the product can be methane, hydrogen, biofuel, energy, chemical and materials, green biorefinery, etc. The recycling concept saves the energy. Every time a new product is made from raw material, large amount of energy are consumed. Recycling products increases the amount of energy it takes to produce these items. And second, wherever you use the energy, you impact the carbon footprint also. Energy used in the area of different product at different level. It is the scenario of increases that greenhouse mitigation. You can see that different waste management option, waste quantity, conversion factor, collection factor, and greenhouse gas emission. ton CO2. This slide shows the greenhouse gas emission saving. The waste sector can save or reduce greenhouse gas emissions through several activities such as avoiding the use of primary material for manufacturing through waste avoidance and metal recovery, producing energy that substitute or replace energy derived from fossil fuel, storing carbon in landfill, and through application of compost to soil. Indeed, the waste sector is capable of generating a net greenhouse gas emission benefit through waste avoidance, material recovery, and energy recovery. There are several technological options. On one side, it is biochemical conversion, and another side is thermochemical conversion. You can adopt. There are several waste management strategy and greenhouse sinks. You can adopt as per your suitability. You can see the input column, material sector, tree, oil, etc. Then raw material acquisition, and the result is energy and non-energy related emissions of CO2 plus increased cutting of trees. If you go for energy, same. So it is up to you which route you want to follow. This is a comparison between landfilling or open dumping versus composting of waste. You can see if you go for composting, it improves soil health, increase soil microbial activity, ameliorate soil nutrient profile, modifies soil texture and water holding capacity, source of employment generation also, augment agriculture productivity. If you go for landfilling, it will lead to soil pollution, air pollution, water pollution, pressure on land availability, health issues, and loss of aesthetic value. The impact of solid waste management is concerned. Virtually every step, along with life cycle impact, greenhouse emissions, solid waste management decision can reduce greenhouse gas emission by affecting one or more of the following. First is energy consumption associated with making, transporting, using, and disposing the product or material that becomes a waste. Non-energy related manufacturing emissions such as CO2 released when limestone is converted to lime. Methane emission from landfill where waste is disposed. So less waste, less methane emissions. CO2 and nitrous oxide emissions from waste combustion. Carbon sequestration, which refer to natural or man-made processes that remove carbon from atmosphere and store it for long period or permanently. This is the figure showing relative contribution of greenhouse emissions from excluding LUCF, which includes greenhouse emissions and removal from changes in forest land. Figure 1 shows the distribution of greenhouse gas emissions by different sectors. You can see the energy sector is highly contributing uh, towards the greenhouse gas emission, and 3% is from the waste. This figure shows the interactive contribution of waste management option to global warming. If you do improper composting or in anaerobic digestion, then also you are going to release methane and CO2. Landfill gas is also has the component of methane and CO2 and incineration also. This is the interaction between selected waste management treatment options and climate change. That you are using that septic tanks, stabilization pond, and landfilling is not if not managed properly, the chances of release of CO2 and methane is there. If they are properly managed, then you can use in septic tank. Methane can be used in power or another sector, power generation or cooking, etc. Clean development mechanism and greenhouse gas emission mitigation in waste sector. At present, developing countries have no obligation to constrain their greenhouse gas emissions, but are still able on a voluntary basis to contribute to global emissions reductions by hosting projects under CDM. As of May 2009, the number of CDM projects in pipeline counted to be greater than 4,200, out of which 1,640 projects were registered with the annual average carbon emission reduction of till the end of year 2012, out of which 17.4% of the CER is distributed in 13 sectors, that is waste handling and disposal, as shown in the next figure. It can be seen that maximum number of CDM projects are in energy sector, and that many are small renewable projects occurring in more than 40 countries. You can see the distribution of CDM projects under different sectoral scope of United Nations framework for climate change. Energy sector has a maximum number of projects of CDM. The registered CDM projects under the 13th sector with the individual breakup from developing Asian countries include India, Nepal, Bhutan, etc. From these developing countries, only 62 projects have registered for CDM under 13 sectoral scope. Out of the 17 projects from developing countries solid waste category, composting of organic fraction of MSW dominated than any other waste disposal practices, whereas the landfill gas recovered from landfill dominated from developed countries, because there the scientific landfilling is very common. The gap analysis. In developing countries, controlled incineration of waste is not practiced frequently. There is open dumping very common because of high capital and operating cost, low value of waste because they are producing most of the organic waste, not, and which have high water content. Difficulties in maintaining the required operating condition as well as history of previous unsustainable process. If you burn the wet waste, lot of energy will be used in evaporating the water, and it will not burn very easily. So waste to energy from wet waste is very costly process. Need to investigate the development of new CDM methodology for waste minimization and management practices and to account of greenhouse gas emissions gained through resource recovery, and provide guidance on application of existing methodology to recycle and waste prevention projects. Support for the informal recycling sector, including recognition of sectoral roles in sustainable waste management and resource recovery, production of waste pickets, livelihood, and improvement of health, safety, and general quality should also be tackled. These are some of the recommendation conclusions. Change in climate change waste management practices has not well recognized and has not yet featured prominently in the environment and economic policy scheme of developing economies. This means that the waste is very ignored sector at the level of climate change. Waste policymakers must have an effective link with climate change policymakers so as to make certain that appropriate waste management policies are adopted to resort towards changing climate, and an industry from the must be established for waste management companies so that they are capable of having a good understanding of potential climate change impact on their environment. You can see that at one side we are facing from energy crisis, and on another side in Haryana, Punjab, etc., Parali is born. If you and on a third side there is a Amul like networking Amul Dairy cooperative society. So the policymakers can plan and collect these waste from Haryana, etc., pile it up and inform a period, etc. They can use these things in the energy generation, and can the open burning can be minimized, and it can help people a lot. They can have some at least something from that pile, and we can use this waste in energy generation and meet our energy demand. So there is an industry forum must established for waste management companies having a good understanding of potential climate change impact on their operation. Waste collection and disposal authority must be aware of any concern that could affect their functional role or responsibility. Problem with the system is that only the air pollution, vehicular pollution are meant for they understand they are meant for the climate change. But the other sources like agriculture sector, waste sector, which is also a very big sector, and as for my concern, there is nothing is waste. If you manage the things, one waste can be serve as a raw material for others. Thank you. Abhishek. आ रही आवाज?
हाँ, यस सर, या आ रही है. अब मैं अनम्यूट नहीं कर पा रहा था. ओके, थैंक यू सो मच सर. नाउ इट इज ओपन फॉर द डिस्कशन.
एक्चुअली प्रॉब्लम क्या है कि वेस्ट मैनेजमेंट को क्लाइमेट चेंज से जोड़ा नहीं गया आज तक, बट द इम्प्रॉपर वेस्ट इज so you can find very less research related to waste management and climate change.
Yes. Only indirectly they are the link with the waste management when it will be the decompose and the carbon dioxide and the methane then.
क्योंकि वेस्ट तो स्मॉल लेवल पे भी और लार्ज लेवल पे हर जगह जनरेट हो रहा है.
हाँ, हर जगह जनरेट हो रहे हैं ये सारी चीजों को, और ये इंडिविजुअल लेवल से लेके कम्युनिटी लेवल एंड इकोसिस्टम लेवल पे और वो सारी चीजों पे मतलब करने की जरूरत है.
क्लाइमेट चेंज रिसर्च करना इसमें प्रॉब्लमेटिक भी है, क्योंकि आप जो ओपन जो घर के लेवल है या कैसे एस्टिमेशन करेंगे.
हाँ जी सर, बिल्कुल.
डंपिंग साइट पे तो आप कर सकते हैं, मगर छोटे लेवल पे बड़ा मुश्किल हो जाता है.
हाँ बिल्कुल. एनी क्वेश्चंस? और क्योंकि इंडिविजुअल लेवल पे आदमी कर नहीं सकता, केवल सेग्रीगेशन ही कर सकता है.
नहीं, इंडिविजुअल लेवल पे ये है ना कि आप अवेयर कर सकते हैं लोगों को उसके यार्ड्स पे और चीजों पे, और लोगों को मोटिवेट कर सकते हैं कि भाई मिनिमाइज करो. और जब इंडिविजुअल लेवल पे चीजें होंगी तो मास लेवल पे इम्पैक्ट करेंगी ही करेंगी.
हाँ जी सर. या आशुतोष, ask the question.
Good morning sir.
Good morning.
लाइक सर रिसेंटली आपने जैसे पॉलिसी मेकिंग की बात की थी, तो हरियाणा में भी, जैसे आई बिलोंग टू हरियाणा, तो हरियाणा में वो पॉलिसी था स्टार्टिंग में वेस्ट डिस्पोजल का, कि हर एक गांव में ऐसे डस्टबिन टाइप का बनाया गया था. बट सर उसके बाद में वो थोड़े दिन ही चल पाता है। लाइक कोई भी अपने पॉलिसी बनाते हैं हम लोग इंडिया में, तो मेरा ये रहा है जहां तक मैंने नोटिस किया है सर, वो थोड़े दिन तक बड़ा एक्टिव रहता है एंड देन आफ्टर वो थोड़ा धीरे धीरे करके वो सब खत्म हो जाता है। लाइक फिर बाद में कोई उसकी तरफ ज्यादा केयर नहीं करता उन सब चीजों की। तो सर उसके लिए
भाई
उस
मैं इसमें जोड़ना चाहूंगा थोड़ा सा। वेस्ट मैनेजमेंट इंडिया में एंशियंट टाइम से रहा है। क्या अर्थवर्म के बारे में लोग नहीं जानते हैं? जो अर्थवर्म खाद है, या गांव में कभी वेस्ट मैनेजमेंट की समस्या रही है? जब से
नहीं।
पॉलिथीन आया है तब से प्रॉब्लम क्रिएट हुई है गांव में।
यस सर एग्जैक्टली।
और रही बात क्या कहते, देखिए वेस्ट मैनेजमेंट प्रॉब्लम क्या है हमारे इस देश की, कि बहुत सारी चीजें ऐसी हैं हो सकती है। गवर्नमेंट का भी रोल है और कमेटी का भी रोल है। अगर आप वेस्ट मिक्स कर देंगे तो गवर्नमेंट भी कुछ नहीं कर पाएगी। तो कहीं ना कहीं रोल ऑफ इंडिविजुअल पीपुल ऑल्सो प्ले अ वेरी रोल इन मैनेजिंग द वेस्ट। आप सिक्किम का बेस्ट उदाहरण है कि वहां पे कूड़े वाला आता है एंड वो दो सेक्टर में ही करता है, ड्राई वेस्ट और वेट वेस्ट। अगर आप वेट वेस्ट नहीं अलग किए, वो वेस्ट लेने से मना कर देता है, आप उसको फेंक नहीं सकते, यू विल गेट फाइंड। और पूरा पूरा वो स्टेट भले ही छोटा है मगर कहीं ना कहीं अर्निंग कंपोस्टिंग कर रहा है।
यस
तो कहीं ना कहीं जब तक कि सोसाइटी अवेयर नहीं होगी, सोसाइटी जागेगी नहीं, लोग अपना रोल रिस्पॉन्सिबिलिटी नहीं समझेंगे, प्रॉब्लम तो होगी। आप गाड़ी एक छोटी सी ट्रेन का ले लीजिए एग्जाम्पल, डस्टबिन होता है सिंक के नीचे, मगर कितने लोग अपनी सीट से उठ के वहां जाना पसंद करते हैं? अगर गलत बोल रहा हूं तो बताइए। लोग ये सोचते हैं कि हर दूसरे सेक्टर तीसरे सेक्टर पे जिम्मेदार आएगा और साफ करेगा। हमारी भी तो रिस्पॉन्सिबिलिटी कुछ है उसको सहयोग करने की। ये तो नहीं है ना कि हम कूड़ा प्रोड्यूस करेंगे और सरकार साफ करेगी। सरकार हम ही से तो है सरकार।
बिल्कुल सही कहा सर। मतलब कोई भी नहीं करना चाहता, इवन सामने डस्टबिन भी रखा होता है तो वहीं से फेंकने की कोशिश करता है कि एकदम डायरेक्टली उसमें थ्रो लगेगा और उसके अंदर जाएगा। तो
अरे भाई बीएचयू का हालत ये है कि डस्टबिन पड़े रहते हैं, कूड़ा डस्टबिन के बाहर आता है, डस्टबिन खाली है। तो कहीं ना कहीं भाई लोगों का जब तक जुड़ाव नहीं होगा इस देश से, इस प्रदेश से, इस समाज से, चीजें नहीं सुधर सकती। मैंने इवन यही आदमी यहाँ रहता है, यही आदमी फॉरेन जाता है। मैंने यहाँ तक भी लोगों को देखा है विदेश में कि गलती से कोई कागज गिर गया, बगल में डस्टबिन है, लोग भले दूसरे का अपना उठा के फेंकते हैं।
हाँ जी, हाँ जी।
तो कहीं ना कहीं लोगों को कनेक्ट होना पड़ेगा, तभी ये सब
सर
चीजें चल सकती है।
अगर हम दिल्ली की बात करें सर, तो दिल्ली मेट्रो और दिल्ली नई दिल्ली रेलवे स्टेशन में दोनों आपको एक साथ अंतर देखने के लिए मिल जाएगा। जहाँ पनिशमेंट है
बिल्कुल
वहां पे कोई कुछ भी नहीं फेंक रहा है। चॉकलेट का रैपर भी आप अपने बैग में डाल ले रहे हो दिल्ली मेट्रो के अंदर, क्योंकि पनिशमेंट। लेकिन वही चीज
भाई,
जब आप
बहुत सारी चीजें डर से होती है ना।
हाँ
हम
जी
इसको
सर।
यही कहेंगे, बहुत सारी चीजें डर से होती है।
हाँ जी सर।
जहाँ अपनी रिस्पॉन्सिबिलिटी नहीं काम करती ना, वहाँ डर काम
वहां
करता
डर।
है।
हाँ जी सर। यस सर। So I think no one next question. Any other question? Okay. So I again invite Dr. Sunita Yadav to give the formal vote of the thanks to our first speaker, and our second speaker, Professor C.P. Kaushik, is already joined.
चलिए मैं थोड़ा सा जल्दी कर दिया।
Yeah, no problem.
Good morning, Kaushik sir. Good morning. So
Morning, welcome, sir.
So it is my privilege to extend a heartfelt thanks to our first speaker of the day, Dr. Rajiv Pratap Singh. We were delighted to hear your talk, and it was in continuation with one of the talks that we had yesterday, sir. So thank you for giving such an insightful lecture to our participants, and thank you so much, sir. Welcome.
थैंक यू डॉक्टर सुनीता एंड डॉक्टर अभिषेक।
Thank you, sir. Thank you.
Yeah. Uh, yeah. Thank you so much, sir. Uh, so I invite Dr. Pooja Kokhle to introduce our next speaker. Otherwise, I request to the Dr. Sunita to introduce to the our next speaker, Professor C.P. Kaushik, sir. And it is my privilege to again welcome to the Professor Kaushik, sir. Professor Kaushik, sir, is known to me in 2009 onward when first time I started my teaching career under his supervision. Just completed my PhD in 2009. Then I joined to the uh, Department of Environmental Science and Technology, Hisar, and a lot of the things I learned from the sir. And so I think he is my first guru who can give to the idea to how can I teach to the in front of the students. So I am always welcome to the sir because that was the first time when I will enter into your MTech class in the air pollution, and you can no problem of music, you can go and you can teach. That time I am really thinking that how can I speak in front of the students, but your motivation is given to me, and now I am whatever I am doing, it is just because of you. Thank you so much, sir.
Good morning, sir. Am I audible, Abhishek, sir?
Yes, yes,
Yes, yes, ma'am.
yeah.
Good morning, Kaushik, sir. It's a pleasure to have you again on a different
Yes.
platform, though.
We
Sir,
are
just for
delighted
the
to have
sake
you
of
again, sir. Yes.
yes, and sir needs no introduction for all of us, but many new students are there in this webinar. We have big numbers this time, so for their sake, I would just like to introduce sir. Professor C.P. Kaushik is an alumnus of the University of Delhi and is the founder, dean, and chairman, Department of Environmental Science and Engineering, Guru Jambheshwar University, Hisar. Sir has, wore many hats in the university and has been Dean Academic Affairs, Chief Warden, Controller of Examiner, and also officiating Vice Chancellor, among many other administrative responsibilities. Sir, academically, he has 40 years of teaching and research experience and has guided 18 PhD students and 3 MPhil students. And also, he has guided 83 MTech students for their dissertations. Sir has been contributing severely to the environmental issues and causes and has a patent on biogas generation system, which is approved and it is doing great in the field of climate change and mitigation and pollution control. He has authored 6 books on environmental issues and also his latest Springer book on climate resilience and environmental sustainability approaches global lessons and local challenges is doing great in this genre of books. Sir has been guiding and pursuing research, and he is also involved in a lot of consultancy services, not only to the government but also to other agencies, and has vast experience on different mitigation of different pollutants such as gaseous, particulate pollutants, pesticides, heavy metals, PAH, to name a few. Sir has been recognized and his contribution has been recognized by the Haryana State Pollution Control Board as well. His research in the fields of pollution and remediation of pesticides and effluents from the textile and other industries has won a lot of accolades. Sir has served in different agencies at the state as well as the national levels and is a member of the Haryana State Environment Impact Assessment Authority and is leading the environmental clearance of developmental projects. He is also an assessor for the National Accreditation Board of Education and Training of Quality Control of India. If I keep on going, then sir's achievements are many. But what is interesting and what is for us to learn from him that he has very, beautifully imbibed and kind of translated his research into policy patents so that what research he is doing is actually going onto the ground and people are helped by that and also his expertise is being used by different governments. So this is, sir, as youngsters, it is a take home for us, and I welcome you on behalf of the organizing committee to deliver your talk, sir. It is a pleasure. Thank you, sir. Sir, I think you are on mute.
Sir, you can unmute yourself. Sir, you are muted. Your voice is not coming.
Thank you, Ananya and Dr. Abhishek. Actually, this much is not required. Basically, I just want to say I am basically a teacher, and throughout my journey, with sincerity and passion and commitment, whatever people achieve, I could also achieve. So thank you for giving a very nice introduction. So not taking much of time because you have already elaborated many things, and let me share my yeah, this is I am audible to all the audience. Hello.
Yes, sir.
Yes, sir.
Okay. I chose this topic, climate change and agriculture sustainability. Actually, initially I did not know whether this talk is for a seminar or for a course. Then Dr. Abhishek told me that it's for the course. But anyway, I have changed it. Earlier I thought of some other topic, but this topic also I elaborately prepared, but then time is only 1 hour, so I'll just discuss few important things out of my presentation. First of all, I want to make it clear the difference between climate change and global warming. Actually, the participants must have listened to basic things, but anyway, it's refreshing to have the difference. Global warming. So once the temperature keeps on increasing, we say global warming. The temperature increases throughout the world, regularly increases. That's the global warming. Earlier we used to use this term only, global warming, but now we have coined another term also, climate change. So climate change is different from global warming in the sense that at places there could be warming, at the same time at other places it could be cooling. So climate is changing in different places at the same time. So that's the difference. So I will tell you why this occurs. Actually, in 2019, when there was a very severe cold in Europe and America, the temperature went down to minus 60 degrees Celsius. It was the coldest ever recorded temperature, and people were not able to stand out of their houses for a few minutes. Then the then President of America, he said, "What the hell is going on with global warming? Please come back fast. We need you." He thought that it's a global warming. Why there's a cooling? So we need warming because at that minus 60 degree, you would like to have the warmth. So maybe it's not that Trump was ignorant of global warming, but he is supporter of coal lobby. Maybe because of that, I do not know exactly why did he say like that. But definitely we know that the temperature when it was minus 60 degrees Celsius in Chicago, at the same time in Australia, it was 49.5 degrees Celsius in 2009, in 24th January. And it went on a few more years, February also, and some the cold winter season extended late, and not only extended, but it was very severe, minus 60 degree. You see in the residential area, this is something which was not normal. You see the ice in Chicago, and you see people taking bath with their pets in the water so that they can cool their bodies. So this is the difference between climate change and global warming. Basic global warming, you must have listened to many speakers now, because this is perhaps the last lecture. So sun rays, they can reach the earth passing through the atmosphere, which has greenhouse gases also. The incoming solar radiations, they can penetrate because they are the short wavelengths, and the earth absorbs these rays and then try to reflect these waves in the infrared radiation range, infrared range. So the outgoing range are the long wave radiations. Incoming, it has the various types of the wavelengths. It is UV, visible, in some these things. So the outgoing are only the long wavelength. So this is similar to the greenhouse. It's called as greenhouse effect. It's similar to in the greenhouse. In winter we have the greenhouse, glass house, where we keep the plants. The rays come, solar rays penetrate this glass, and they are not able to go out because the IR radiations, long wavelength, they are not able to pass through the glass. So similarly in your car, if you park the car in the summer outside, so you have got the interior very heated interior. So this is the greenhouse effect. So actually what happens, you must have seen.
Excuse me, sir. Sir, do you are using any PowerPoint, because your PowerPoint is not visible, or otherwise just lecture? I am just asking.
Oh, it's not, screen is not visible.
Yes, sir. Yes, sir. Not visible.
Why? It should be visible.
Oh.
Okay, let me share another screen then.
Yes, yes.
No slide is visible.
No slide is visible.
Then it doesn't make sense. Okay, just let me. You should have told me, because. Okay, I'll share another. If that PowerPoint will be. Is it okay? Okay.
You can open the. No,
yeah.
sir. You can open the PowerPoint into your screen, laptop. Then it will be visible.
Yeah. Is it visible now?
No, sir.
Okay, let me.
Sir, you are share the entire screen or something?
Let me. I don't know why it's not.
Sir, you can again share.
Just. I think I'm there. Let me. Okay. Upload. Is it visible now?
Yes, sir. Something is coming.
Okay. Yeah. Sorry.
Yeah.
Let me just give you a glimpse of the past few slides. This is the climate change and global warming. This is what I wanted to explain. I have explained it. And then global warming. Up to this, I have discussed, right? I think it's okay now. Is it okay?
Yes,
yes, sir. Okay.
Okay.
Yes, sir.
You can.
Now, what we see, the yellow lines, this is a sun, these sun rays, they're coming here. And once some of the rays, they are reflected back by clouds and all these things. And the rest of it, this is absorbed by the earth, and some of it is sent back as such. But this is a yellow. As such, the solar radiations in whatever wavelength they are coming, they are reflected by the earth, because we have got some very nice, you see, shining surfaces and all that, they are reflected. But the absorbed one, they are red colored, arrows. So the absorbed ones which are reflected back into re-radiated from Earth to atmosphere. So some of them they pass through the radiative active window, and most of it they come back. So this bigger portion of the IR, this remains in the atmosphere. Therefore, the high clouds which are scattered, thin clouds, they warm the Earth more than the thick clouds which are near the surface. You see that most of the infrared radiations, they're not, they go out, and some of them they come back. But the atmosphere of which they have been there, it's very less distance as compared to the scattered, the high in height, the clouds. So this is how there are many. This is about clouds, carbon dioxide. There are many greenhouse gases: methane, nitrous oxide, even CFCs, and nitrous oxide, water vapors. So they are the ones which are called as greenhouse gases. So they they contribute to greenhouse effect on this earth. Now climate change. So let's see what is climate. We have different environmental parameters. The variability of its properties. Properties in the sense that temperature, relative humidity, and all these change environmental conditions, if they remain practically almost similar and extend for a longer period, that's climate. Like we have here on the television, they say daily, you see, weather report. We know what's the temperature, what is the relative humidity, wind speed, wind direction, and all that. But if we talk about climate of Shimla, it's cold, and it remains cold for majority of the time. And likewise, climate of Rajasthan is hot, because this is when the variability of the properties are not too much and persist for a longer period. That's called as climate. And where it keeps changing, that's the weather. So today we have different weather. We may have high temperatures, low temperature, wind directions. This is weather condition. So, but this is not, it will take much time, because whatever concentration of CO2 in the atmosphere we have, on 12th of March this year, the concentration of CO2 was 419.19 ppm. So 419 ppm in the atmosphere. So this is regularly increasing. So if we do not stop or mitigate the emission of carbon dioxide, we will have the RCP, representative concentration pathways, of 8.5, the top you see line. So it will increase the temperature to the tune of 3.7 degrees Celsius as compared to the pre-industrial era. So this is how we see the temperature increase, and we have to have RCP of 2.6 when we can have 1 degree Celsius, and the atmospheric CO2 concentration should be 475 or less. And in the worst scenario, it will be 1313 ppm of carbon dioxide equivalent. When we say equivalent, this is all the contributing gases, methane, nitrous oxide, carbon dioxide, and whatnot. So these gases, the total concentration in terms of CO2 level, so it will be very high. So this is a very, we can have a mitigation by stabilizing carbon dioxide emission, and further mitigation that we can achieve the concentration of 475, which will be increasing temperature by 1 degree Celsius as compared to the pre-industrial time. So here, if we have these are the projected 3 scenarios: the lower, middle, and the high. And if we see in the last 30 years, there have been numerous shifts in the climate belts. and abundance of species has also changed in these climate belts. And if we have these scenarios, if we do not control, the temperature will be very high. If we stabilize, it will be in the middle path. If we mitigate, it will be lower. So even then, some species on the terrestrial surface on the earth will be prone to extinction. For example, 20% of the earth species are expected to be extinct, or they will have the risk of extinction. And the different scenarios, the low, if we control, even then 18% of the species, mid-range 24%, and maximum change 35% of the species. As I discussed about the representative conservation pathways, they will be prone to extinction. So we have to rapidly implement the technologies for control of emission of CO2 into the atmosphere. For that matter, other greenhouse gases also, so that the temperature does not rise and we save our species, because species extinction will jeopardize our ecological balance. It's not that only few species are important. All the species are important, and some of the species which are they provide food. If they become extinct, what will happen? We can't say at this moment. It will be very severe condition. Hunger will be there. I'll discuss that. So who tells us all these data, all these data and projections, what will happen? So there is an intergovernmental panel on climate change, IPCC. It's a network of 2,500 world leading climate experts. 195 nations are its members, and they are studying the climate regularly, and they are monitoring the concentration of greenhouse gases also. So if we have a look of the past climate, for the last 8 lakh of years, we have been observing some interglacial and glacial periods. Glacial extends to over 1 lakh years, and interglacial, say, average 12,500 years. So we are in the present last 10,000 years, we are in the interglacial period where the temperature is conducive for supporting of life, maybe animal, microbe and human life. So this is the Anthropocene. Anthropocene is a period, it may extend by another 50,000 years, because we now experience a global warming. So it can extend, but we have for the last 10,000 years, another 2,500 years or so, or 3,000 years will be interglacial period. Then we will have the glacial period where maximum of the globe will be covered by snow. So effects of rising temperature. Now we know greater sea level rise, increased precipitation, rainfall, and we will have droughts and floods at different places, hot days, heat waves will be there, and melting of permafrost and ice caps. Permafrost is permanent frozen, you see, areas in northern and southern hemisphere, Arctic and Antarctic is permafrost, and more intense tropical cyclones that we just see, they keep coming. And because the oceans absorb atmospheric carbon dioxide, there will be ocean acidification. The pH value, due to absorption of carbon dioxide with water, it will make carbonic acid, which will dissociate to form hydrogen ions, and which will cause acidity. And the salinity will also increase in the oceans, and which will not be good for survival of the aquatic flora fauna. There will be insect outbreaks. Insects of crop and human vector of disease, they will increase. And countries like India, where the agriculture and fishery sector will be highly impacted, so we will have our food security will be in danger. So now the question may come to your mind as to how the temperature of the globe is different. Some countries are cold countries. They are the temperate countries. Then others are tropical countries, the warmer countries, some subtropical countries like India. So how the globe is able to maintain the temperature of the globe in different parts differently. So we know, I suppose you have studied this Earth. On the equator, we have got the hot temperature, and then we have the winds blowing. All winds also blow because of the difference in temperature at different regions. We have easterlies, we have westerlies, then the cold deserts are there on the top poles on both the sides, north and this thing. So here on the equator, when the air warms, warm air becomes lighter, it tries to go up. As it goes up on the this thing you can see here, as it goes up, so it expands and cools, and cooler air is heavier, and then it comes down. So once it comes down, so it whatever uh, water is you see held in that cloud or the air, once it's compressed, so it will rain here. So we have different and where the moisture evaporates here at the equator because it's high temperature. So we will have the moisture deficient areas, or some parts they have deserts and some parts they have got the green vegetation. So it is this. So wherever this water falls, it will be having high vegetation. Wherever this goes up, from here it goes up. So it takes the moisture up, and then it you see moves down here and allows the water to come down. So we have the deserts here and good vegetation, tropical rainforests here. This is how we have different distribution of animals and plants over different latitudes and altitudes of globe. So therefore we find that this is how the temperature is maintained. And oceans also help to maintain the temperature, because we have got the poles which are cold, the Arctic, northern pole, and Antarctic, southern pole, they are cold. So water in the middle is hot on the surface water. The hot water goes towards the poles, and then at the poles it becomes cold. It goes down, and then here when it comes up, because there's upwelling in the ocean. So because of the nutrients also have to come to the surface. So there's upwelling, and this upwelling is controlled by difference in temperature in the lower, you see, layers of ocean and the upper layers of the ocean. So this is important for sustaining flora and fauna in the ocean, as well as distributing the temperature. Therefore, we have got different, you see, temperature, which is controlled by temperature in different parts of the world. Then you must have heard about El Nino, southern oscillations. In normally the heat flows from Southern America through Pacific to Australian this thing. But in the El Nino, it is reversed. So from Australian part, it goes to Northern America, Southern America, like that. And this is because of the temperature of the ocean. Ocean temperature increases, and therefore the winds which are hot, they move towards, this is a reversal of normal procedure, of the normal path of air movement over between these two continents, over ocean, Pacific Ocean. And here, once this air currents move, they take the evaporated moisture also, and this takes moisture and causes rain in Indonesia, Jakarta, and all these parts. And they depend upon these rains for extinguishing the fires which they set in the forests to clear the land for developmental activities. If the El Nino fails, the jungles will burn, and this happened a few decades ago, and then lot of devastation occurs. So these are the basic phenomena which distribute this heat across the globe. Now, having studied this, now let's see what's the behavior of ocean. How does ocean control global warming? So it removes about 30% of the excess CO2 pumped into the atmosphere, because we have to have some CO2 in the atmosphere which is required for the photosynthesis by the plants. So, but we are additionally putting CO2 because of our industrial activity and other activities, and ocean absorbs about 30% of this, and the absorbed heat from the lower atmosphere has been able to increase the temperature from 3.2 to 1 degree Celsius. 1.2 actually, this is old data. I did not make changes in this. This is 1.2 degrees Celsius in the atmosphere increase as compared to the pre-industrial temperatures. Then carbonic acid, acidity, they affect the microbes and food web in the ocean. So it's a very staple food for the peninsular parts of the these countries. The ocean surrounding the terrestrial areas surrounded by ocean, so they depend upon seafood. So carbonic acid, acidity, and increased salinity, this you see disturbs the microorganisms and the food web. So this is how the ocean will be experienced with the increased CO2 concentration or the climate change. So now high temperatures, seawater will expand. We see when we have the we boil water on the heaters, so water evaporates. By heating, it expands in volume, so the volume will increase, sea level will rise, and melting of polar ice and polar caps, and melting of the icebergs, which will melt, the cutting of the melting of the permafrost. This will also bring water into the ocean. Sea level will rise, say, by half a meter by 2050, and the flooding of the coastal areas, this countries like Shanghai, Bangkok, Sydney, Hamburg, Venice, Lakshadweep Islands, London, and Miami. Miami is a very precious piece of real estate. I have seen, this is Miami. It's surrounded all around by ocean, so it has a connection here with the other parts, but you go by air also. So I have seen Miami. It sits on the calcareous rock. The earth is calcareous, calcium carbonate. If the ocean acidity increases, so it will combine with CO2 plus carbonic acid. It will dissolve the earth on which the city is developed. So it will sink. All of this Miami will sink. So the other coastal areas, cities, they will be having the coastal aquifers. They will be having coastal erosion. The seawater will contaminate the coastal aquifers. Aquifers are the, you see, water which is having this is below the earth, and we have confined and open aquifers, the good quality water, and the coastal erosion will cause this seawater to contaminate these aquifers also, and salts will also go into the water, and decline of fish catch, because the fish will be washed away to the shores, or the and they will not come back, they will die. So, and the flood will cause oil and other hazardous chemicals which are stored in the coastal areas. So we think that they are safe, but once the sea level rises and the waves, they will go to coastal region. When they come back, they may bring the hazardous chemicals and will contaminate the ocean. So cloud covers, high temperature, more evaporation, more clouds, and more clouds, they will rain out within the, you see, ocean itself. They will not reach the land. So the rainfall pattern will be erratic. you will have rainfall, because now agriculture cannot be rain fed. We do not know whether in which period the temperature, the rain we will have rain or will have the drought. So therefore, this is because of increase in temperature, more evaporation, the clouds over the ocean itself, they will be capturing more water, and they will be heavy, and they will rain out either in the ocean itself or on the areas of land near this thing. So the trajectory which is seen in the different countries will not be maintained. Low and thick and continuous clouds, they will reflect and again, we do not know what exactly will happen. Global warming can increase global warming. Global warming can cause cooling, global cooling, because if the clouds are more, the incoming solar radiations will be reflected, or if they are darker, they will be absorbed. So we do not know how much clouds will be able to allow the incoming solar radiations to Earth to provide the heat. So high altitude and thin disk continuous, this I have explained. They increase the surface warming. Ice shields. In the past 30 years, Arctic snow has melted and 10% decrease is there. So it will decrease in the reflective ice. So Arctic ice is like we have the snow and we have the ice. Ice becomes, snow is loose, isn't it? And ice becomes hard surface and shining surface. So it reflects the solar radiations. So once it melts, the shining surface will be lost. The underlying greener surface or darker surface will be exposed. So they will be attracting more sunlight. They will absorb more sunlight. Therefore, we see in the summer we wear white clothes, and if we wear the dark clothes, it will be absorbing more heat. So likewise, if the shining surface, white surface is lost and the darker surface is exposed, so that it will be absorbing more solar light and it will increase the surface temperature. Permafrost melt will be increasing release of methane, because this is permafrost is the upper frozen layer, and soil, ice and all that is there in the Arctic region, and below this is water. So the organisms which remain in the water below permafrost, they respire. So because there's no oxygen, so there's anaerobic respiration and methane is produced. Once this permafrost melts, methane will be liberated. So Arctic snow, if it melts, it will increase the global sea level rise by 7 meters, and only 1 meter or 2 meter rise in the sea level will inundate the coastal cities, like I discussed before, and flood lowlands and deltas where we raised our crops, especially the rice, which requires more water. So therefore, in the coastal areas and lowlands, we raise rice crops, paddy crops. So if this is inundated, if the floods are there, so this crop will be destroyed. Now we have prolonged heat waves and droughts. So the huge toll of ecosystem where we need colder temperature, if droughts are there, more rain is there. So it will disturb our soil fertility and the crop. Standing crops also will be destroyed and the germination will be affected. Warmer and wetter tropical climate, it will give you more vectors of disease like malaria. We heard of malaria only. Now you hear of encephalitis, yellow fever, dengue fever, so many other fevers. So they are there. So because the insect pests also increase, the crop pests also increase, because their increase depends upon the temperature and relative humidity. So if the exact combination of relative humidity and moisture in the atmosphere, relative humidity and temperature combination is there, so then the reproduction of insects increases. If the insects happen to be pests or vector of disease, so they will cause lot of damage to vegetation and human health. So if we find the temperature increasing, the temperature, suitable temperature will be there, and high temperature will evaporate more water. RH will also increase. So wherever this combination will be available in which part of the world, so it will be increasing the pest population, insect population. Now at places we find that there is a drought, and we see the areas which are in the tropical, subtropical region in the globe, like Amazon forests, Amazon region in the Southern America, South America. So the one which is having this band, this here we find Amazon forests. They have frequent this forest fires. Excuse me, I'll just. Hello. आपको कहते हो कि आ जाए और मैं खोल देता हूँ दरवाजा, घर के अंदर रख देगा उससे ना, मैं बिजी हूँ. Yeah, so we have here Amazon. We frequently see on television that forest fires in the Amazon. In Australia also there are many forest fires. In California also there. These are the ones which are having they are near this equator or subtropical conditions. So what happens in the jungles when it's all dry? So even winds which are moving, the dry leaves, they will strike against each other, or some other this thing. The forest fires occur. So this is beyond your control. So big forests are there. Once forest fire is there, most part of the jungles, they are destroyed. And last, you see the forest fire. This is a kangaroo. The animals here in the middle of the forest, they are not able to get out of this. And there are certain barbed wire also to demarcate the area of forest. So they are not able to go, and they're burnt as such. So much of animal life and plant life, this is destroyed because of the forest fires. And if the temperatures further increases, so the frequency of forest fires will increase. Now, yes. Now, as I told you that at certain places there will be drought and high temperature, at other places there will be cold temperature. So if you recall, some 3-4 years ago, we had very severe cold conditions, because in America, Europe, Canada, we had low temperature, as I showed you in the first slide. Even in Rajasthan, temperature was below freezing point. Temperature of Rajasthan is very high, but that year it was below freezing temperature, and the chill was linked to breakup of the polar vortex. And I have just shown you in the air circulation model that airs, they move around the globe, they go up, they come down, but in the poles, there's a polar vortex, because I'll just show you in the next slide. And the Arctic, this spill in the Arctic, Europe and US, this was very severe. This allowed this spill of the cold atmosphere, cold air, to come down from Arctic to Europe and US, and the western disturbances which bring the air from these regions to India also. So they further caused cooling in northern India, especially during that period. Oh, this is the one. Here the air which is coming to the poles, it's moving like the movement of a top. लट्टू जैसे घूमता है ऐसे होती हैं. Then this forms a polar vortex, and this polar vortex is differentiated from the lower part of the globe temperature by the jet stream. Jet stream, I've shown you jet stream. Okay, I cannot go back to that. The moving of the air in the Hadley cells, you see the going up, coming down, but at the poles, it's just moving like that. So this stream jet does not allow the warmer air below this with the colder air up this thing. But during that period, what happened? The temperature of this increased in this lower part of the globe. So this pushed this jet stream upwards. So it was like this. So upwards and downwards, it was just like the zigzag path. So wherever this was pushed here, so this came down. So these finger-like projections, they brought the cold or the crystals of ice or cold air into the parts. This is South America. So up to this, North America, Canada, Europe, all this had the extended part of area below polar region. So this extended downwards because of the upward push, because of the high temperature of the lower part of globe, subpolar region here. So this caused, and we had the westerlies. So from the Europe, the westerlies, winds which are coming from west. On the west, we have got these countries. So these westerlies, they bring colder air. So from here, or this was the reason that we had very biting cold in the northern Indian states also. So climatic stability, it maintains the vegetation pattern, and food production and population is stable. Once this climate stability is disturbed, we will have the changes. If the changes are gradual, we can adapt. If they are very severe, then we'll be having various types of the problems, because some of the areas which are growing food, they will be will have the hostile environment, so it will not be able to produce the food crops for you, and there will be premature deaths, and biodiversity of the earth will decrease because many species will die. That I'll explain the next slide. So they say if there is a increase of temperature by 1 degree even, the species will migrate. The migration of the tree species will be slow. Tree species, they migrate because their seeds, they spread, and then they germinate, then there grows the plant, and then they germinate, they spread the seeds. Like 9.9 kilometers per year they move, the forest spread. And some species like beech species, this is crunch. It's a tree, it will not be able to spread, so it will die out because the temperature will not be conducive, and high altitude will have nowhere to go. So if they will actually, this is now, first you see this thing, 1 degree temperature increase will cause the species or climate belts which have different, you see, agricultural belts. Agricultural climate belts, they have different agriculture areas which agricultural crops can grow in that area, in that belt. So it will be moving northwards by 100 to 100 kilometers. Northwards means from equator to North Pole. This is latitudinally 100 to 150 kilometers, but upwards 150 meters in altitude. Like you start from for Shimla, you have got different type of the apples, Shimla apples, then Kinnaur apples, like they have different size, different taste, different. So even altitude wise, if we see the same crops are not growing, they will have different this thing. But altitude wise, 1 degree, the crop belts will increase, will change, move 150 meters. Means what crops are growing here now, they will be now growing high 150 meters above. So there you see you will not have the conducive conditions of soil or humidity. Likewise, if you see from equator to poles, 150 kilometers. Kilometers means you have got the productive soil here. You may not have the productive soil there, because we make the soil productive by adding fertilizers and other you see ingredients or requirements of the. So you may not have tubers, you may not have other transportation means, you may not have railway stations to bring fertilizers and all that. So all these things, just by 1 degree temperature uh, rise in global temperature, global mean temperature. So this is, we see, I think you understand what's one degree. Otherwise, daily temperature 1 degree doesn't make much difference. We have temperature here of 2 degrees Celsius in winter and 49-50 degree. This is the local temperature. Global average temperature is when we take all the countries, their temperature average of this. So 1 degree as compared to prehistoric, pre-industrial, you see temperature, 1 degree increase in temperature, global average temperature. This will cause this temperature increase. So the productivity depends upon fertility of soil and infrastructure. I have discussed, if infrastructure is not there, fertile soil are not there, and then deserts are there, so crops will not be able to grow. And we expect that we can have 1 to 3.5 degrees Celsius as per different models, the temperature increase by next century. So then, so this is many this species will become extinct, and there will be forest diebacks, massive extinction of plants and animals in the forests, because they will not be able to migrate, and the fish will, and the polar animals and plants, they don't have even the few kilometers to move around, because then there's globe ends, earth ends at the pole. So wherever they go, they will become extinct. And if the temperature rises, that the water bodies, lakes, streams, the water will evaporate, and the concentration of pesticides, it will increase, and the aquatic flora fauna, it will die. So wildlife reserves, wetlands, coral reefs, our parks, they will all be disturbed by increase in temperature. Now, recent extremes in weather affecting agriculture. This is just a compilation of different news, or in different years, the ones which are alarming, saying that this is abnormal, which is not the normal trend, and this is a trend which we observed. I just read out because it's difficult to remember. Record-breaking low precipitation over parts of Western Europe during December 2016. If the rainfall is not there, you can expect what will happen. Unprecedented reduction in Arctic sea ice. So if the Arctic sea ice is reduced, so that methane will come out. In 2017, South Korea experienced the hottest May temperature since 1973, 17. You see, for those many years, this was the hottest May, and certain things which require May normal temperature, they will be disturbed. 2017 was the 4th consecutive year of record-breaking May temperature. In the northern plains in US, devastating drought during spring and summer. Droughts in spring you don't expect, but then in 2017, 16 and 17, they were the ones which had the abnormal environmental this thing. By August, drought was widespread in different parts of you see, and wildfires and the loss of water sources or decrease in water sources. Severe drought in Indonesia caused poor harvest and water crisis. Models suggest that the low precipitation was principally because of the drought, but climate change may enhance this intensity of the droughts, etc., 1.5 times more. So you can expect that since 1973, it was normal, and 16 and 17, this was, I just have taken the data for 1 year only, and in between you have got many such environmental abnormalities of temperature and rainfall because of changes in climate. Then is now Paris Agreement, United Nations framework on climate change, framework convention on climate change, UNFCCC. They hold meetings, and the Paris Agreement says that the global average temperature should be maintained well below 2 degrees Celsius. Earlier they thought that 2 degree, up to 2 degrees it's okay, but then we see that beyond 1.5 degree it will be very difficult to sustain the ecosystems. Therefore 1.5 degree is no, but 1.5 degrees Celsius, for that level we have to have stricter national determined concentrations of emissions, because all the countries are advised to have their NDCs, nationally determined concentration of greenhouse gases. They should be controlled and they should be reduced. It gives, but if the temperature is allowed to increase by 2 degree, then there will be catastrophic effects in the developing countries, especially like the countries, subtropical and tropical countries like India, because their temperature will be very high, even by 2 degree average global temperature increase. So we have already reached up to 1.5 degrees Celsius current climate. So we just need 0.3 degrees Celsius increase. By it will be very easily attainable by 2030. So it's not 2022. Another 7-8 years will be reaching 1.5 degrees Celsius, and our control of emission is not that stricter. So if we go beyond that,
I think there is some network issue at sir's end.
Yeah, I am also thinking that same thing, because we are not audible to the sir. So we will wait for the some time. Yeah. So might be the sir will be the again join.
I think sir will again. I think.
Pooja, hi.
Yeah.
Hello,
There
ma'am.
is a power problem in sir's end. So sir
Hmm.
will be the joining within the 5 minutes.
Okay, I was thinking maybe the problem is with my
No.
network.
Basically, the power cut into the Dwarka,
Okay.
and sir is saying that the generator will be the start. It will be take near about the 5 minutes in the apartment.
Okay.
So we will wait for him.
Okay.
Yes. Yeah. In between any participants, anything wants to discuss with us, they can ask. Because during the validatory session, which will be the held after the fourth session, we will circulate the one feedback form. So you can basically fill all the feedbacks. There is some objective. You can select the one option, and there is some questions. You can write one or two lines. So there is in the text. So we will give the proper time. You can fill. There is no hurry. You can fill within the half an hour. So after the validatory session, you can fill and submit to us before 11:59, because after that the date will be the change. So automatically you will be the late.
Writing the
You will be the late
everyone
for
will
the 1 minute,
fail.
but the electronic and the digital era, you will be late for the 1 day.
Will that matter? I mean, will you penalize him for them for that, Abhishek?
No.
Or
I am not that one. But why they are the late? Is someone is asking? Might be the principal, or
they
they
must
are
be
sending
thinking
the
so
message.
hard, no, to answer
So,
the
so we
question.
will be the answer. So that's why I am requesting and giving to the instruction to the all the students and the
Yes.
participants. You can
Yeah,
feel
just
before
pushing your leg.
11.
It's okay. Yeah.
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 So already because we will be the complete the all the task up to the 5 o'clock. So there is the 7 hour. They can feel. Yeah.
Absolutely. Absolutely.
Yeah. Don't think we will be the feel in the next day. That's why I'm saying that.
Yeah. Okay.
So this is the fifth session, and after that, the one session is the more after the post lunch, and there is the two more speakers, and
And
both are excellent. And hopefully, the first one is the totally the differ and geological aspect of the human, how they will be the change with the climate change. So Professor Tripathi will lectures will be the totally different prospects.
are you keeping track of Dr. Kaushik, Professor Kaushik?
Yeah, just receive the phone call. The wait for the 5 minutes.
See,
Of
power
course,
backup is so useful, na? If you have power backup,
yes.
so useful.
Yeah, in my apartment, it will be the automatically power
Exactly.
cut.
Even in our apartment, Delhi, we are used to power cuts, no? So we already have the power backup concept.
Yeah.
In
So,
smaller areas,
yeah,
they are not.
sir is the again joining. Welcome, sir. Unmute yourself, sir.
I'm sorry it took longer time. This the power doesn't go normally, but
Yeah.
and the
No,
generator
uh,
automatically starts.
yeah,
Okay.
this time we will utilize for the instruction of the feedback.
Okay, okay, that's good. That's good.
Students. Yeah.
So let me see. Is it okay? Is it
No,
visible? I have to
no, your slide is
So, sir,
not
you have
visible.
to again
upload again.
make it.
I'll upload again. Is it okay now?
Yes, sir. Now it is visible.
Now, yeah. So we'll be very soon reaching 1.5 degrees Celsius increase in temperature, and earlier US up till now was not contributing funds because it did not include itself in the decision making for climate mitigation. But Biden now is taking keen interest in climate change mitigation, and therefore till now US did not, and now it's having plans and programs and contributions for this cause. And because okay. Yeah. Now, climate change and agriculture economic survey 2017-18. I have some you see projections or now here what happens now. Impact will be twice as large in the unirrigated, and in the irrigated also will have the impact. Temperature and rainfall, if they are not conducive, the rainfall and temperatures required for irrigating the soils and for maturity of the grains, temperatures is required. If the temperature changes, the income of the agriculture income will decline 20 to 25% in the unirrigated, and irrigated it is average 15 or 18%. This thing. So in nutshell, the change in climate change may cause a decrease in agriculture productivity and hence the income of the farmers. Kharif will be affected less than Rabi. This will be affected more, and rainfall dry days, rainfall less than 1.1 mm per day, and wet days when the rainfall is 80 mm per day increased steadily in the last decade. We have got dry days more and wet days also more. So this is the parameter of deciding dry and wet days. Temperature extremes in the northeast, Kerala, Tamil Nadu, Rajasthan and Gujarat, the extremities of temperature are felt more in these areas, and their extreme temperature 4° decline in Kharif and 4.7% decline in Rabi was observed. Extreme rainfall shocks 12.5% decrease in Kharif and 6.7% in extreme rainfall shocks. If the rainfall is less, not only temperature, but the rainfall shocks are there, then Kharif, because Kharif is the summer crops. When we sow the crops in summer season, Rabi is we sow the crops in the winter season. So if the Kharif crops are not getting sufficient rainfall, then naturally the decline in production will be more than the Rabi year. Temperature, of course, is reverse. Rabi is cold, we need more temperature. So in cold temperature, if it's beyond this required temperature, whether it's Kharif or Rabi, and rainfall is also not normal or it's abnormal, when we have the temperature and rainfall shocks. So this is two different levels, different percentage, maybe small 6.2 or 6%, 4.7. Both the crops, there will be Rabi and Kharif, they will be affected by variation in temperature and rainfall extent. Now, severe cold wave conditions, they will affect northern states of Jammu because they are already cold. So if cold conditions are there, the temperature will go further down in Jammu, Kashmir, Himachal Pradesh, Uttarakhand, Punjab, Haryana. To some extent, they are in the northern parts, so they will be having. Then the peninsular region, the lower part, which is the India part, which is having sea on the sides. Frost, both on the ground and the plants, they will put crops at risk. So if the water on the crops, leaves, etc., it starts freezing, frost. So naturally the vegetation in Maharashtra, which vegetation will be there? Gram and seasonal vegetation in Maharashtra, they will be affected. Brinjal, cumin, jeera and mustard in Rajasthan, because these are the crops which will be more affected. Coriander, potato and gram in Madhya Pradesh, and Punjab, Haryana, Himachal Pradesh, Uttar Pradesh will also have the reeling, will be reportedly reeling under frost related crop damage. So frost, when if the frost in that at that time when the leaves have some dew on them and the condition is cold, in different areas, different time will have this condition. So at that time, whatever the crops are growing there, for example, Maharashtra, I've told you, Rajasthan, I've told you, and Madhya Pradesh. So these are the three different areas of different latitude. So they will be having their crops which are growing at that time when the frost can occur because of the low temperature in the atmosphere and moisture on the leaves. So these areas, they will be much affected. Combination of low moisture and clear skies along with calm winds. So this will be increasing the temperature, ground temperature, because the clouds, when they are there, low clear skies. The clear skies will allow the heat to go out. So it will cool the temperature. If there is a sky, the heat will, if the sky has clouds, the heat will be reflected back. So then there will be a lot of heat on the surface. So combination of low moisture, clear skies and calm winds. Winds will not be able to distribute heat, heat will go up. So this will be ideal condition for the ground temperature to fall sharply overnight, increase chances of ground frost. So the temperature will increase and ground frost will occur. So you see, I mean, now this simple one point will determine the change in you see climate, low moisture and clear skies. So again, we have seen that the clouds, the climate change will affect the distribution of clouds in the sky, and it will affect the moisture in the atmosphere. So here, if this is meeting these conditions, then the frost will be there. The frost on the leaf surface. The plants will have the frost, the moisture will freeze, and then the crop will be damaged. So this is all controlled by climate. Cold wave, dry weather, they form dangerous combination. Dry weather and cold, even for us, in winters when it's a dry winter, our lips start cracking, isn't it? Skin becomes very dry. So similarly for the plants also, cold wave and dry weather, they are now they are very harmful for the crop growth and yield of the crops. A layer of frost on stem, leaves and fruits. Plant cells, they rupture. If our lips can rupture, the plant cells will also rupture, and this will be ground frost limits the availability of soil oxygen and moisture to the plants. So this is another parameter which will decrease the. So this is called as a physiological drought. Physiological drought is when we have moisture in the soil, but plants are not able to pick up this moisture because of the, for example, frost conditions. Even soil oxygen will not be picked up, moisture will not be picked up. So this is called as the physiological drought. So the things are available, but the conditions will be as we observe in the drought condition. So this is all controlled by the climate. Global warming, the climate change, temperature above 2 degrees Celsius will cause the loss of wheat by 46%, rice 90%, maize 31%. And additional loss will be causing increased pests, increase in pest crop insects. They will further damage the crops to 10 to 25% of the yield. Loss from pest infestation will be largest in China, US and France, because these are the three countries in the world which are producing most of the grains. So there will be more pest infestation there. And at present also 10 to 16% of the global crop production is lost to pests, insects, fungi and bacteria. So if suppose you know that the temperature, fungi and bacteria also they increase, the number increase depending on moisture and temperature. So they will be causing damage to the crops. Even stored grains, they will also be destroyed. Climate change could alter the activity of 38 of the world's most studied insect crop pests. I think most studied means the ones which we are using as a staple food. This wheat, rice, bajra, all these are ones they in the 38 crops, because different countries they use different food crops for their dietary needs. So desert locusts, they feed on rice, maize and sugarcane. They will be stripping the crop fields within hours. So we have seen how tiddy dull locust can destroy the standing crops. Now here you see that this is the, if this violet purple is a metabolic activity. If the temperature increases, the metabolic activity of the insects increase. Metabolic activity means they will be eating more food, they will be destroying more crops. And if the temperature increases, now above pre-industrial area, the population is one is the only feeding will increase. Now population will also increase with increasing temperature. So these two scenarios that tell us that the increase in temperature will be increasing the population also and their feeding habit also. So different crops, wheat will be having this type of scenario, rice will be having, rice pests will not be increasing in population, but their feeding activities will increase. And for the maize, it's almost the same. If the temperature increases 1 to 5 degrees Celsius above the pre-industrial level, so for different crops, these are the major crops, wheat, rice and maize. So you will have, there's an increase from 40 megatons. Megaton is trillion tons, trillion kilograms. 1 megaton is 1 trillion 100 crore kilograms is 1 megaton. So this is 40. This is the one which we have normal current loss without increasing temperature. So if the temperature increases, we'll have 60-80%, not percent, megatons per year of this magnitude. 80 megatons per year will be loss of maize, this much loss of rice, this much loss of wheat, because of the increase in the metabolic activity, more feeding or increase in population. So this is how the temperature increase will give you the crop loss. Future crop productivity scenario. Because it's difficult to know how much this thing will be affected, because net effect will be that if CO2 increases, then you see the photosynthesis will increase. But if the temperature increases, loss will increase. So the loss and productivity will be changing to different extents. Sometimes the net loss may be 0 or it may vary from 20 to 30% over the next few decades. Because 0 means CO2 will enhance the productivity and temperature will enhance the crop failure and insect attack, pest attack. So therefore, it could be 0 or it could be. So it depends upon the extent of CO2 elevation and the temperature increase. Likely scenario 1.5 degree per decade, while the CO2 increase will be almost the same, and the yield depends upon the crop themselves, and we have to have the genetically modified plants to resist the temperature and have more responsiveness of the crops, because we have the genetically improved crops which can resist temperature and humidity and moisture in the soil. So wheat management changes, we have to see what type of and when and where and how we have to grow the crops depending upon which areas experiencing what level of the climate change. So if we are not able to control it, then we'll have the crop productivity this reduction. Now only 2-3 more slides. With the population increasing to 5 billion by 2050, right now we are about 7.9 billion people in the world. It will grow to 9 billion by 2050. Agriculture crop the production will need to increase by 60%. And we see in this scenario by 2030 will have increased by 1.5 to 2 degrees Celsius, and it will reduce the crop substantially. What will happen? Population will increase, food product is less. So there will be sort of competition or scarcity of food. And if climate change, water scarcity and land degradation would reduce the food production by 1/4, and people will suffering from hunger. So we have to link our needs to the climate change. Food security. There was a lecture I read in the pamphlet. So I want to elaborate on this. When we have, when all the people, depending, irrespective of their race, caste, creed, physical, geological, or distribution, physical, social, and economic level, they have sufficient and safe nutrition, food, which meets their dietary needs and food preferences for an active and healthy life. So that is called a food security. We have to provide every individual sufficient and nutritious food depending upon his choice. It's not that in the parts which are where people eat food, you give them, where they have rice, you feed and give them wheat. They will not be able to enjoy. The people who need their meal in sufficient amount with nutrition content, nutritive content, to the extent they fulfill their dietary needs, irrespective of their caste, creed, and level of income or social aspects. So that is food security. And for national food security, we should have the availability, access, stability, and utilization. Availability, production, sufficient distribution. We have the government distribution system, ration shops, etc. Decreased price, we distribute, public distribution system, low cost, this thing, and we can exchange, we can availability. If the people don't have money, we can have the barter system. Access, even if income is low, we have give the food aids. Food aid means like some states they say 1 kilogram, 1 rupee, 1 kilogram rice will be given, like that. It's a food aid or public distribution system. Stability, supplies and access should be stable. It's not that you are not able to make it reach the local area. So wherever the production is there, you have to supply this so that everybody can access the and utility, nutrition content, food safety and human health. They are considered for utilization. So you allow the people to utilize full content of nutrition and etc. This is the 4 dimensions of food security, and for that we have to adapt, reduce our this emissions through mitigation and sequestration of the global greenhouse gases, and therefore we'll be able to reduce our emissions. Thank you. We need the crops to be protected because we don't have any other bee planet where we can raise the crops. So therefore we have to be careful. This is just it's not a specialized lecture. This is just to make people aware that we do not contribute to global warming, because not only food crops, all the ecosystems will be affected, and we may not have the system to support our life so far as food is concerned, our life so far our other needs are concerned. Even we may not be able to properly respire. So therefore we have to make the climate stable. Stability of climate is to be maintained, and deterioration is to be prevented. So thank you very much. I have tried to speak little faster because I wanted to cover within my allotted time, but I don't know how much you must have gained, but whatever you have gained, I think that may give me satisfaction, because in such lectures with the limited time, best I can give you, I have tried to give it. Thank you very much.
Yeah, now the participants, if you are having any query or any doubt or any things, any question, you can ask to this sir.
How many participants you have, Dr. Abhishek?
Yes, sir.
How many people are logged in?
51, sir.
51.
Yeah.
So I expect some good questions.
Yeah, Nachita, you can ask your question.
Has raised his hand. Nachita, you can go ahead with your question.
मैं ज़्यादा फास्ट बोला, समझ ही नहीं आया कुछ. Dear participants.
Pooja, if the participants are asking, उसके बाद I will also ask a question to sir.
Yes.
Yeah,
sure.
because I am thinking that there is the problem at the Nachita end. Initially she raised hand and after that disconnected. So ma'am, you can ask your question.
Yes.
I can ask. Thank you. Sir, Professor Kaushik, as usual, it was a very, very riveting lecture. You managed to, the impressive thing was you managed to tie up global scenario to India's Rabi Kharif crops to the physiological level of plants. That is probably the first time I've heard climate change being related to a cellular level. So that's absolutely very, very interesting, sir. I have a couple of doubts.
Yeah.
One is very theoretical. That is, do you think there is any part on this globe which will not be affected by climate change, in your opinion?
Very difficult question. You see, even Arctic and Antarctic regions, they are also being affected by climate change. So from equator to poles, all parts are affected. Yeah, it is a different matter that the effect will be variable. For example, it may be beneficial, it may be harmful also, because if the temperature increases in the tropical, subtropical countries where the temperature is already high, so it will be more detrimental. And for the regions, for example, the colder countries, if the temperature increases, so it will be maybe beneficial for the crops to grow, because we know that, and it may prevent the or decrease the number of HVAC, because if these are cold countries, they use heaters. In the winter, if the temperature increases, then they will not be using heaters. They will save on electricity. But this is a hypothetical this thing, because climate change is not only temperature increase or decrease. It encompasses other parameters of climate, of environment. For example, relative humidity and all that. So the effect may be variable. For some time it may be useful, and even in some parts which are permanently always you see covered by snow. So there, for example, Iceland, there the vehicles move on ice. If that ice melts, trucks can move. So movement of trucks on the exposed land will be easier. So that is they will be beneficial. But if suppose the ice freezes, then in those areas where they have got the ship you see transportation through water, if that freezes, ships will not be able to move. So that is a disadvantage. To which level, which part of the globe will be affected is difficult to say. Actually, if you know that there's a book, Perspectives in Environmental Studies. That's authored by me and my wife.
Okay.
Perspectives in Environmental Studies. It's a UGC compulsory course book.
Yeah, most of the students will be using this book, sir.
And in the new syllabus of UGC, they have given some topics, and I have written elaborate on this. So your question, you can find some of the answers there in the climate change, effect on agriculture, effect on different this thing on ozone layer, or the effect of ozone layer also, ozone depletion. So various new topics are there. So this climate change is also elaborately discussed there, but it will be having different magnitude of impact on different regions, equator, subtropical, tropical, and polar also.
So just one more, again a conjectural question. One more.
Yeah.
We have promised for a net zero emission by 2070. You think that is okay? Because I think we are far away from that, and 2070 may be a little late. I mean, according to all the talks that I have heard so far.
Yeah, it is too late, because I told you that by another, at this speed, we'll be reaching 1.5 degrees Celsius by 2030, or maximum by 2045 or so. 2070 is too far stretched. By that, we do not know whether we'll be able to survive or not, because I have another presentation where I can discuss that above 2 degrees Celsius, the globe will burn. The globe will burn. It will have runaway reactions where additional CO2 addition is not required. It will be self-catalytic, and temperature will keep on increasing, and thus the earth will start burning. It will be so high temperature. So at that 2 degrees Celsius will attain very shortly. So 2070 is too far. Too far. It's not realistic. But then when it was set, at that time we did not think that the changes will be so fast, and we are not able to control the emissions. Therefore, the IPCC keeps on changing the targets from 70. Now they say 2050, and 2050 then will be somewhere 2030. So that's how we evaluate the emissions and then the deadlines.
Thank you, sir. Thank you so much.
Okay. Welcome.
Sir, please ask your question. We can see you raising your hand.
Hello, sir. Good afternoon.
Good afternoon. Yeah.
Sir, there was network problem earlier. Sir, my question is the action and the strategies the different nations are adopting. So I wanted to know these are enough to mitigate the direct impacts of climate change, or isn't it too late? And related to this question, is there any way to reverse the impacts of climate change?
Yeah. Actually, it's not, number one, it's not sufficient and it's too late. Our attempts are not sufficient because you yourself think that our every conceivable activity is contributing to climate change. Do we really, as at the individual level, we try to control? No. And the nations in the, you see, in the race of attaining prosperity and development, in the name of development, they are producing many unnecessary things which are not required for their survival. There are so many industries are spewing so much carbon dioxide and other chemicals into the atmosphere. So we, or rather consumerism is increasing. We are consuming unnecessarily more things than ever because we are developing and we have got more income. So earlier when we had to meet the basic requirements for survival, we did not use these things. So therefore industrial activities are less. So now this is not realistic. We are not attempting that. And then it's too late for us to. So second question is reversal. Reversal can be is not that easy. It can be, you see, we can maintain the status quo by our sincere efforts. The level which we have reached CO2 emission, we decrease it, and already pre-industrial area at that level we have to reach. So that's very difficult to go back. So our population is increasing, our requirements are increasing, food requirements, every needs are increasing. So therefore, now at this level, we have to have population control, which is again another difficult proposal. Indira Gandhi tried to do it, but then in 72, but then she failed because it was you see, conducted operation, and control of population, control of emissions. These two things can stabilize the environment. But to talk of reversal, I think it's very difficult.
Okay, sir. Thank you so much, sir.
Okay.
Yeah. Yeah. Any other questions, sir? If
Yeah, any questions? Because there are so many aspects which within the limited time we cannot you see, discuss, but they must come to your mind. There are many aspects of climate change.
yeah, of course, I know you will be go to the most of the my student in the first years. They will be go to the examination for the open book examination. So firstly,
Okay.
you can open your brain, then you can
Yeah.
easily find your answer into the book. Otherwise, it will be very difficult to find out and
No,
just start
actually,
pages.
Dr. Abhishek, open book examination is not that you remember the page number and copy as such. It's
Yes, sir.
rather more difficult than the non-open book examination, because in the open book examination, the questions are not straight, and
Yes,
the straight answers will not be available in the book. So I do not know for COVID, this examination system, they may give you straight questions which you can find the answers there. But
no, it
open
is
book examination is
yeah.
difficult.
All questions are the twisted. They will
Yeah, they're
identify
twisted.
the questions
Yeah.
and then they can write. And this
So
will be the
we tried the indirect question mode, but it was resisted by students as well as by teachers.
Yeah,
So
yeah.
we have gone back to the straight question mode.
No, it's difficult to coin or make such questions.
Yes.
For teachers also, I don't undermine their capabilities, but they can, but it takes time. And
No, actually there was resistance in Delhi University about that. And these days we are only evaluating photographic capabilities of students, how well they
Yes.
photograph and send. That's it.
Yes.
They just take a photo and send it.
That is true. That's true.
It has defeated the purpose of open book exam actually.
Yeah, that's true.
So without wasting up the time, I invite Dr. Pooja Gokhale to give the formal vote of the thanks to the sir, because the sir is our partner, and whenever I am given to the invitation, sir will be the always agree. Not only the sir, ma'am is also agree with these things. Professor Kaushik ma'am and Kaushik sir both are the agreed, and student, if you are the not reading the book of the Kaushik sir, so you can take the book, and it will be the use for your open book examination also. So now invite to the Dr. Pooja Gokhale to the give the formal vote of the thanks.
Thank you, Abhishek sir. It gives me a pleasure to thank sir. Sir has been an integral part of this add-on course since we began 3 years back. And time and again, whenever we have had seminars and these intellectual deliberations, sir has always kindly agreed. In spite of his busy schedule, he has always found time for us. Sir, we thank you for that on behalf of the organizing team and all the participants also. Your lecture today was very lucid. It took us through the journey of climate change and also what future can hold us for in the terms of climate change, because what basically climate change is affecting is our agriculture, and not only the crops that we eat, also other organisms which are dependent on their pests, the pathogens. So this integrate on the complex relationship between all the stakeholders in ecosystems is affected by climate change. And in your lecture you have very beautifully expressed that what all can happen to us. The food that we eat is actually going to, face the brunt of climate change, and we are going to be affected adversely. I don't think so anything else than food and something that is very basic to our existence. If it is being hampered so badly by climate change, we don't need anything else to convince people that yes, it is very much there and affecting so much of us that is a part of us. Sir, thank you for such a beautiful lecture and addressing all the queries of us. Thank you very much, sir, and hope to meet you again, probably in the offline mode very soon.
Yes, sir,
Thank
in
you,
the
sir.
offline mode as soon as
Yes.
possible.
Yeah, welcome and thank you very much for nice words. It's my pleasure. Always
Yeah,
my
thank you,
pleasure
sir.
to interact. Thank you. Thank you.
Yeah,
Thank you, sir. Thank you so much.
Okay, bye.
and
Thank you.
thank you, sir, and all the participants, because morning session is the over, so we can again meet at 2 p.m. for the final and the sixth modules. And after just the two lecture, as I already said, so everyone will be the join at 2 o'clock, and to 4:30 when both the lecture will be complete, we will enter into the validatory mode. So now it will be take the break and join at 2 o'clock. Thank you so much, everyone.